So in this video, we're going to talk about slope and rate of change. So let's start out with a couple of definitions. So the rate of change is just talking about the relationship between two quantities that are changing. So if we said that one quantity depends on the other, then the following is true. The rate of change means the change in the dependent party over the change in the independent. And when we talk about the dependent, we're talking about the the y over the x. Okay, keep that in mind because your y is always dependent and your x is always independent. So then we talk about slope. Slope is a number that describes the steepness of a line. Slope is rate of change. So people use slope and rate of change interchangeably. Slope, which is abbreviated with M, not S, M, is the vertical change over the horizontal change. Keeping in mind that when we look at two axes, the vertical is y and the horizontal is x. So again, we're talking about y over x. So slope and rate of change are the same thing, and slope is talking about how steep your line is. And we're talking about vertical over horizontal, or y over x. So how can we find slope? So let's say we have a graph and we need to know the slope. Then we're going to use the following. Rise over run, because the rise represents our y-axis and the run represents our x. So let's look at this first graph. If I start from this point, which in this case is -1, 1, I'm going to rise up 2, and then I'm going over 5 until I'm at 4, 3. Okay, so I rose up 2 and I ran 5. Well, since slope is rise over run, I could say that I rose 2 and I ran 5, so our slope of this graph would be represented with m equals 2 over 5. And anytime you're trying to find it from a graph, you can draw this triangle and just count up 2 and over 5. And this represents a positive line. It looks like you're climbing a mountain. So this one, which looks like we're going down a mountain, is going to have negative slope. We still look at rise over run, even though our rise happens to be going down. So here's my triangle. We're going down and over. So how many are we going down? Well, we started up here at -1, 4. And I'm going down 1, 2, 3. So my rise is -3. And then I went over here to, again, 4, 1. I'm going to go over 1, 2, 3, 4. Wait a minute. 1, 2, 3, 4. So that must be 3, 1. Sorry. Ah. All right. So my run is 4. So I would say that my slope, my m is going to equal -3 because my rise went down 3. That's why it's negative. And my run was 4. So for this graph, my slope is -3/4. So again, if it's going up, when you look at it from left to right, just like we read, angling this way, your slope is positive. If it's going that way, like you're walking down a mountain, your slope is negative. Slope is abbreviated by m, and it is your rise over run. Okay, so what if we don't have a graph? What if we just have some ordered pairs and we need to find it? Okay, so you can picture where these might be when graphed. So we have an algebraic formula. To find it, remember slope is rise over run, or change in y over change in x. We'd say y2 minus y1 over x2 minus x1. That is our formula. So I can come here and label these. This is x1, y1, x2, oops, that's an x, y2. So if I want to use my algebraic formula to find my slope, I would do this. My y2 is 7 minus my y1 over 5 minus, this is -2, -2. So to get my slope, I'm going to do 7 minus 1, so the top is 6. On the bottom, I'm going to do same, switch, change, and get 7. So my slope is going to be 6 over 7, or in other words, I would rise up 6 and go over 7. Okay, what about this one? Let's label it again. x1, y1, x2, y2. So I would do -6 minus 1 over 1 minus 0. Okay, so same switch change up top. Negative 6 plus negative 1 gives me negative 7 over 1. So in this one, I'm going down 7 and over 1. So for every 7 that I go down, I'm going over 1. So this is your formula that represents slope, your change in y over change in x. And again, it is y2 minus y1 over x2 minus x1. It's very important that you remember to do the y's on top and your x's on bottom. Rise over run. Okay, so what if we have a vertical or horizontal line? This changes, well, it doesn't change how you solve your slope, but these two are always going to have the exact same slope. Let's say we wanted to use our y1, our x1, y1 rules here. Watch what happens. So in this horizontal line, when I do y2 minus y1 over x2 minus x1, I'm going to get 0 over 2. So when I get the 0 on top of a fraction or on top of a division problem, the answer is always 0. So therefore, we can say that our horizontal line, the slope of it, is always going to be 0. And if you look at it, there is no rise. It's all run. So this one is just going to run, no rise. So that's why it's 0. It has a rise of 0, a slope, and a run of whatever. But we would just say that that is our slope. Well, what about a vertical line? So look what happens here. I can do my y2 minus y1 over my x2 minus x1. So up top I get negative 5. On the bottom I get 0. Well, you never want 0 in the bottom of a fraction. So when you have a vertical line, your slope is undefined. Why is it undefined? Because we're not going anywhere. We're just going, it's up and down, straight up and down. So it's undefined because it does have a rise, but it has no run. So when we have no run, we say that it's undefined. It's not sloped, it's steep. This one has 0 slope, this one is undefined because it's just completely steep. If you fell off a hill, you certainly wouldn't want it to look like this because you're falling straight down. And those are the types of slope and how you calculate slope, and we're going to practice more of this and learn how it relates to a line.